Okay, even though this problem, part C, doesn't require an answer, just needs to set it up, I do want to go through how I would use the calculator to do cylindrical shells and discs and washers. So let's assume then that this particular problem asks us to find area, then revolve around the x, then revolve around the y-axis. And I'm going to show you how I would use the calculator to set that up. First of all, you should be able to see how I set up 64x to the 1/4, that particular function, and x. So I put the 2 in there, and if I went over to graph, I could see the intersection of the two curves right there. I could go ahead and find my 2 points of intersection, um, which I believe you understand how to do. Second calc, intersect is 5. We start with the first curve, which is 64x to the 1/4, then x, then guess, and that gives me the intersection at 0. Then I go for my second intersection, and 5. I'm going to move up closer to the other one, and the first curve is 64x to the 1/4, x, guess, and it gives me 4. So I have my points of intersection. Now the next thing that I'm going to do is go in and set this up so that I can find the difference of those two curves. So I simply vars y vars function, and my top function is 64x to the 1/4, which is y1, minus vars y vars function y2. I do need to go over and turn them all, the other ones off, off, off. Now I can graph the two functions and see what area I have. Go ahead and find the integral of that from 0 to 4, and it finds that as 4.08. If I was to store that in alpha c, and I said that my answer for that particular one, I believe, was, well, that's one that we weren't asked for in this problem, but the area under that curve would be 4.8 something or other. Alright, I'm going to go on from there. What I want to do now is go back in. I want to find the washers problem, that is the volume of that region revolved around the x-axis. So I'm going to go down, and remember that that's a washers problem, so that's going to be pi capital R squared, which is my y1 vars y vars function y1 squared, minus vars y vars function y2 squared, close parentheses, and now I have my washers problem. When I go over, and it doesn't look anything like the problem that I had, but I'm going to second calc 7 to integrate between 0 and 4, and I get an area of 67.02. I'm going to store that alpha d, just another variable, and compare that to what I thought I had, which was 64 pi over 3. 64 pi divided by 3, and that shows that we got the right answer there. For the final one, I'm going to set up the cylindrical shells. First, I'm just going to deactivate the one I have there. Remember that cylindrical shells is 2 pi, and I put a parenthesis there, but it's not really necessary. Remember that R is usually just your x, and H is the difference of the two. I will need that in parentheses, and that's going to be vars y vars function y1 minus vars y vars function y2, close parentheses. You can see the 2 pi rh there. Go over to find the graph. I integrate from 0 to 4, and I'm done. Now we didn't have to find this answer, so we have nothing to check it against as well.